In this last part of a 6-part series on subtypes, supertypes, we contrast modeling using subtypes and supertype with the notion of inheritance and reuse that comes to us in the context of object-oriented system design and software construction. Even though many data modelers are confused and consider them the same, I would explain why and how they are different.
How does subtype, supertype, the way we talk about it in data modeling, differ from how it's talked about in the OO world? Because it's different. And a lot of authors don't recognize that. Get this right here. Chris Date wrote a paper, and that's one of the ones that's in the readings. He was somebody who did understand clearly the distinction between the OO notion of subtypes, supertypes, and the database notion. So, in the database world, we use it as a design question. It's based upon the characteristics of populations. We could have multiple populations with some different characteristics that share some common characteristics, so we define a supertype. Okay? And looking in the other direction, if we have a subset that requires special treatment, then we set up a subtype. And the rule we've been saying is that the subtype always inherits all of the attributes in the supertype, because it is the same thing. You're a member of both populations. Okay, you're a member of the supertype and a member of the subtype. If you're in the subtype, you have to be in the supertype. Well, that's one of the things that gets violated in the OO world. Because in the OO world, their goal is construction. It's efficiency of implementation. And their goal is not accuracy in the modeling. Their goal is in the reusability of code or definitions. When they talk about subtypes, the focus is on inheritance. But inheritance only, and they're going to use inheritance as a way of decreasing the workload or of reusing code. So it's the inheritance of definitions and procedures for efficiency for implementation. The problem is, in the OO world, you'll hear them talk about blocking. You'll hear them talk about overriding. And what they're saying is that a subtype can block inheritance of information from the supertype. Or a subtype can override something from the supertype. Or if they get the same information that's coming from two supertypes, they can set a priority rule in the subtype that tells them which one to pick. Okay? But that is all violating the notion that you are a member. You're the same thing in both populations, both the subtype and the supertype. Okay? As soon as you hear somebody talking about, in the context of subtypes, supertypes, or inheritance, talking about blocking or overriding or whatever, you know that they're talking about the second notion here of subtyping, supertyping. They're on multiple inheritance conflicts, resolving conflicts, having a priority ordering on the inheritance. Okay? So, let me give you the way it is in the OO world to think about it. First of all, everything in the OO world is an object. An object is always an instance of things. There's no typing. In pure OO, there's no notion of typing or classes. Okay, that was something that was added later, and in fact it was added for efficiency purposes, and they recognized that, hey, if it's good in the data modeling world, maybe it's good here, and that's true. But in the pure OO, there is no typing, so we have everything as an instance of an object. It's like the bottom row of that pyramid that we had. And the definition of an object includes methods, that's the code that's used to do the processing relating to the object, the variables, sometimes called the structure, and the values of those variables. And that's all inside and encapsulated, that's why I've got the green circle around the object. And one of the rules in the object-oriented world is you don't penetrate that encapsulated envelope. The way the OO world, the way everything works is objects send messages to other objects. And there has to, of course, be a mailman. And that's called the object request broker. And there are standards out there for object request brokers. And the message itself will say, which object am I sending this to? What is the operation that I want performed? And any parameters that are necessary. So the message gets sent to an object. An object, the operation tells it which method to use, which chunk of code to use. It will execute that code, produce a result, and send it back. Usually send it back to the calling object, but not necessarily. There are three kinds of inheritance. The first kind is from object to object. In this case, I'm saying, I want to build another object. Can I make use, reuse something that was in this other object that I built, or that exists? And so what I do is I say, I want to inherit what's from that object. First of all, it can be selective. Take what you want, leave what you don't. And it could be that I take that copy only at create time, or I want to make sure that if there's any downstream changes to the object, to my parent object, that those downstream that will be reflected back in this new object automatically. Okay? This is the notion of linking and embedding. Oftentimes you are asked, for example, when you're building a web page, you have two choices. You can either link to a graphic or some other portion of a page, or you can embed it. And when you say embed it, that means it's going to copy it and store it permanently in this new object, in this new web page. And if the original one ever changes, that will not be reflected in the new one. Okay? That's if you're copying it or inheriting it create time only, or it could be dynamic inheritance, where you're only just going to store a link, and every time that new object wants to reference something like that, it always goes back to the old object to find out what it needs. Okay, so that's object-to-object inheritance. And notice, neither one is talking about populations of things. This is just on individual. So one of the next things that we do is we say, oh, we notice that there's some commonalities across objects. So what I'm going to do is I'm going to pull out what those commonalities are, and I will define a thing called a class. It's exactly the same as we call a type. Okay, an object type or a template. It has all of the common attributes. Some may even be optional. But usually it's the methods and the variables. So it would be things like, what are the column headings? What's the name of the class? And you leave the values in the instances. That makes sense. Sounds familiar, doesn't it? It's like a table. This is now the second kind. It's class to object. The object instances inherit the definition from the definition of a class. Well, the third one is I can recognize commonalities across classes. And when I do that, that's when I bring in the notion of a supertype or a superclass. Okay? Three kinds of inheritance. And when we talk about subtypes and supertypes, that's all in the context of populations, not individuals. So it's only that third one between a superclass and a subclass. Okay. And the superclass, subclass, that creates a hierarchy.
I trust you've learned something useful in this 6-part series on subtypes, supertypes. Let me say that among data modelers, even professional data modelers, this is a subject which is not well understood, and hopefully this will help. The limitations in data modeling tools often confuse. I have tried to show you the full breadth of subtypes and supertypes and the constraints on them. to give you a whole context in understanding the concepts. You may also check out my hour-long recording and presentation as part of the Big Challenges in Data Modeling series that was held with Dataversity. Be sure to check out my other lecture segments from my advanced data modeling class at the Carlson School of Management, University of Minnesota. I'm still working toward my goal of getting all my lecture material up on YouTube, so subscribe to my channel. Thanks for listening.